Okay.
So,
Um, 1918. Oh, okay. It's so the longest peak that you see where it looks like it's like a 1700 is the C double bond O. And then the peak, the 27, frick. Actually, before I say that, how did I know it was a H, C double bond H?
is it like a
Yeah, and then
sp3ch? No,
the
that's
peak right here at the 300, the alkane stretching is 2850 to 3000.
hmm.
And
I'm
that's
guessing that's just like the CHs, right? In the al
yeah, and
in the
that's how I was able
alpha.
to identify. I was like, the F was the only
Hmm.
one with the carbon to H bond.
That's right.
That's just how I figured out. That's how I was able to like differentiate. Because there's no alcohol present, there's no broad bond.
Hmm.
There's no CO bond. So you just kind of have to like, if you can't tell, just try to cancel out the other ones
Hmm.
based on what's not present.
I don't even remember why I picked A. It might have been for the C double bond O, but I think I just missed out on that the upper
C
range.
double bond C, maybe you thought it was that second peak was also being shown
Maybe.
because the C double bond C.
But I guess you're right. Like seeing a lot of the squiggles up there in the 3000 range, kind of that's like the
Yeah, that'll show you that there's a CH bond present. And then anything lower than that. Wait, I think I did look. Hold on, I might be. Oh, sorry. Okay, my bad.
okay.
That's not how I differentiated it.
No, what did you
Um,
do?
the carbon to H bond is for an arene is shown at 690 to 900. That's what I differentiated. So that second
690.
longest peak,
Uh-huh.
if you look at the correlation
Oh
tables,
no, yes.
why is this blurry? Okay, never mind. If
I
you look
see.
at the
I
correlation
see. I
tables
see.
on the
Can I share my screen? Yeah, I see what you mean.
iPad, yeah, it's the 690 to 900 because I was kind of
I think so.
confused. That's where I found the second largest
The
peak.
like the thumbprint area, she says, right?
Yeah.
Like that area, like the
Hmm.
yeah.
Where it's like unique to its compound.
Okay.
Yeah, that's how I found out. Because I was like, these kind of mini peaks. I don't think I would have paid attention. Okay. Yeah, nice. Any other questions?
It's just those two for the Okay, so for 18 though, for the highest frequency carbonyl bonds, you said that it is the one that does not have frequency,
Let me let me
that does
read
not
it.
have what's it called? Resonance structures
Hold on,
for
let me
some
see.
reason.
Um, Someone
Uh,
said 18 is 3 since no resonance structure can be made to make the double bond single. But I thought you could make it
3.
single.
Oh, well, okay. Um, I didn't realize like that was the logic, but I'll show you how.
I can
Uh,
try to ask.
boom, boom, boom. Okay, so for this, I'll show you how. Do you see the whiteboard?
Yeah.
So for this, okay, so if I move, like, let's say, if I move this bond down, right?
Yeah.
It doesn't have anywhere to, tr like, now this, hold
Oh, are
on.
you saying like
Okay, like, if
because
I
they
move
were
this
to
double
be
bond
like
here,
this?
and this is positive, right?
Yeah.
This carbon has too many electrons on it because it used to have, like invisibly, that carbon has
Two
two
H's.
hydrogens on it already. Yeah, it already has an H and an, let's just say it has two H's. So
Yeah.
if I move it down to be down here, it's like maxed out. You can't do that. But with like
That's
with
true.
all the other ones, I'll show you for the top one. If we move that down, you can move that down here and this over there like that.
That
Because
makes sense.
before it used to be, wait, not like that. What was it?
How do you erase? Oh, there it
Like
is.
that. This carbon only has what, two? Two, four. Yeah, only has
Yeah.
two hydrogens on it. And it can take one more. Two, four, six, eight. Doesn't matter.
Okay, that makes
So
sense.
basically, the rule for like resonance, like moving electrons around,
Yeah,
is if there is a gap, like if there is a one space gap in between, they can move.
if
Like
there's
for this
room to
one,
add another electron pair.
yeah, like for this one. See how there is this like one space gap right there?
Yeah.
That means you can move it. You can move this down here and this up there. So it will be, oh my goodness. So it would become this, become like that, and then like this.
Okay, yeah, that makes
Yeah.
sense.
So
I
anytime there's
wasn't
a one
even,
space gap from the oxygen.
yeah, I wasn't even thinking resonance had to
Me
come
neither.
into
I didn't
play.
realize that had anything to do with it, but okay. Apparently. That's pretty cool.
Alrighty. Okay, that's
Um,
good. So we understand that one.
mhm. I found it was the announcement. It was the like getting ready for the week game plan thing.
Okay, where she had
She
the slide.
says, no, she just says bring Scantron 3x5 index card pencil eraser.
Oh,
Um,
so we just print, I'm assuming you can either write it or print out
I can
your
print it out.
chart tables.
I'm guessing. I feel like
Oh,
she'll tell us on
yeah, on Tuesday. No,
lab
she's
day.
not here
Yeah,
Tuesday, I thought. Is she? I don't know. Whatever. Yeah, maybe we'll find out on
I don't know.
Tuesday. I emailed her regarding the bond stretching if we have to
Mm.
specify that, but she hasn't replied back, so I will let everyone know in the Discord
Okay.
when she does. For
Was there a
ex
question?
so we look at question 13.
What is it?
Ju-
Ring
Okay.
strain.
Um, I memorized this, but
Okay.
it's basically this, it goes smallest to the highest. So the smallest one has is like, let me draw it out.
Yeah.
Um,
Um,
where's the pencil? Oh, there it is. Okay.
where's the pencil?
So when you draw cyclopropane, its ring strain is 60 degrees, and it's the furthest basically. You have to like draw the whole like axis thing. But basically 60 degrees is the furthest from 109. So your ideal is
Mm,
109.5. That's your like ideal number. And then cyclohexane has a bond angle, bond strain, or I don't want to say, I don't know if it's a strain. I think it might be a strain. Whoa, whoa.
yeah. Angle strain, I think, or something.
Of 120. And it's because 120 is the closest to 109.5 out of all four of them.
Hmm.
Um, cyclohexane has the least strain, the least
It's
ring
the
strain.
nicest one. Yeah, the
Yeah,
least.
because cyclopropane has 60 degrees, cyclobutane is 90 degrees.
Mhm.
I forget cyclopentanes, but that would be like the second closest if we were to be asked.
Like if you have to like rank them or something.
Yeah, but you most
Yeah.
likely won't have to. Yeah.
Wait,
Yeah.
where's? I think there was a question on that too. On the exam. I mean, on the quiz thing.
Was there?
I
Oh,
think
something
so.
similar.
Where is it?
I wrote up my study notes here.
Yeah, sort of. 17. Which of the following compounds gives a com
Okay, okay.
similar, I guess.
It's from oh, oops, my bad. It's from chapter 4. Um, if I can turn off this. Okay, there. So, this is so, can you guys, is it in reverse or can you
I see
tell?
that. No, no, it's fine.
Okay, I mean inversed. So you see
Yeah, I see.
cyclopropane is right over here,
Hmm.
and it has a 60 degree, it has a like 60 degree angle inside,
Hmm.
and then a 49-degree strain.
Like it wants to be more open, but it's
Yeah,
being
but
forced to be an acute,
cyclohexane right
like an
here
acute
is the
angle.
closest to the y-axis. The strain is so minimal,
Hmm.
if that makes sense. So each of
Yeah,
these
cool.
structures, if you
I think
draw
that
them
makes
out,
sense.
um,
Yeah. The question I drew it here. The question for
yeah,
the quiz was which of the following compounds gives a carbonyl bond absorption at the highest frequency? And it was this one.
yeah,
Yeah.
because it's the biggest strain.
Hmm.
Yeah, the carbon to carbon to carbon bond are compressed from 109.5 to 60 degrees.
Cool.
So there's a torsional strain. I hope I said that right. Of
Original.
the eclipsed hydrogen interactions. There you go.
Yeah.
Okay.
Okay, question 15.
Let me pull that up.
I have it. It's just like a text question. Which of the following statements is not true regarding the conformation of substituted cyclohexanes? What is it? It's conformation of substituted cyclohexanes.
Oh, for this one, you basically need to just remember is when you're looking at conformations and you're trying to determine, what am I doing? And you're
I don't
trying to determine which conformation is more stable, just literally memorize this.
know.
Your chair conformation is always going to be more stable than your boat. That's why C is chosen because that's
Because
incorrect.
it's not true.
Yeah.
I see.
Regardless, your chair conformation is going to be more stable than your boat. And then the twisted boat, wait, barnacles. Actually, I think twisted boat might be in the middle. Let me check
We
my
can look
notes.
this, we can look this up. Is
I wrote it
twisted
somewhere.
boat.
Is less stable. Yeah, so boat
Twisted boat
conformation is
is
less stable than the
it
chair.
says twisted boat conformation is more stable than boat because it
Okay, yeah,
relieves
there it goes.
strain
I knew I did something wrong.
between the two flagpole hydrogens.
Twisted boat. I wrote post. There you go. There you go. Okay, that's the official
Okay.
like order to memorize. And then the boat conformation is when the carbon one and carbon four are pointed at each other, right? Because you draw it
Uh,
out like a boat. That's what I did. That's how I memorized it.
the
It's
carbon
like,
one and the carbon four.
yeah, like that's why it's least. Pretend this is a boat.
Uh-huh.
But like your carbon one and your carbon four, the chain are like bent towards each other. I'm pretty
It
sure
is,
it's a
yeah,
boat.
it is like a weirdly shaped, like it's like
That's why it's
I
less
don't even
stable.
know how to like draw that.
Yeah, that's just how
Yeah,
it's connected
like
in my
that,
head.
sort of, right? Kind of.
Okay.
Yeah,
Shout out Anki. This is the only reason why I memorized all this stuff.
seriously. I don't use
Okay.
it too much for chem, but for everything else I do.
It
Okay,
actually helps
go
a lot because I'll
for
post
chem.
like structures on there
Mhm.
and then like I'll try to guess what the structure is like just doing it. Like I'll post like
Mhm.
images on it. Okay.
Okay.
Um, so what's the next one? We went over 13,
Uh,
15 for your response.
Free response 2 and 4.
Okay, so that's on the nomenclature. Okay, so number
Just nomenclature.
2. Oh, I suck at this. Do you know how to do this?
Nomenclature, yeah. This is weird. I mean, I guess it's just telling you to like this, you just turn it into a line structure, right? I guess for people who can't see it. It looks like that, like that, like that. Hydrogen, then like that. Um, so just, remember that you have that this is like one carbon right there, and then
Yeah.
this is your back carbon, which just means there's a methyl group back there because there's three H's. So like we'll do that, um, hold on, that, sort of. There you go. I think that's literally the structure, right?
Is it? I never get
Yeah.
this. Okay. So
So
you're
you have so like this carbon right here is this one, and then the
the
green
met
one,
the
the
methyl
green
group is
one
right here.
back there is this carbon. Yeah. So
Oops.
these hydrogens are like right there. And then you see how this blue one has a hydrogen here. Oops, sorry. I missed the hydrogen. Choo-choo-choo. Hold on. There
So
we go.
even though there's nothing written there,
Oh, for that one, I think that's a. Oh, I see what you mean.
there's not, isn't that not CH? I mean, I'm just guessing, but would that not be
Oh
CH3?
no, you're right. You're right. That is CH3. So there's like one more. I just thought yeah, there was just straight up a methyl group right here, like in the back, right? That
Yeah,
one.
so that would be the H the green H is the CH3.
You just add one like there, like that. Okay,
Oh, okay, and then the
that's
CH3
why.
right there.
That's
Okay,
why you
that
have
makes sense.
your 1, 2, 3, 4, 5 pentane.
One, two, three, four, five. Nice.
Mhm.
Your substituent is on your
Just the
second. Yeah.
shortest order, yeah. It's just two method.
Wait. Mm,
It is really small on the picture though, like that. You're right, I almost missed it. I thought that was an H for a second.
no, you're good. Okay. Okay, yeah, that makes sense. Okay.
Yep.
Thank you. I suck at chair confirmations. I mean, not chair confirmations.
At the Newman
Human
projections?
projection.
Yeah.
I like I only can get half of it. I understand the front, but I can never like imagine the back. But thank you.
Yeah.
Okay.
What else?
So we did
Question
two and then four.
four. Oh,
Okay.
these ones.
These are my favorites. This was actually on the pop quiz.
Was it? Yeah.
Yeah, it was.
Yeah.
We can I can attempt to draw it.
How do you decide? Is it just the bigger side, like the bigger number goes first?
Yeah. The
Yep.
bigger numbers first, and then your inside. Hold on. You're supposed to read from, did he say, I don't think actually it matters left to right. You're supposed to read, figure out the whole structure, how many carbons there are. So like if it's like a
Mhm.
propane, butane, while the structure is not being drawn. Nice. Okay.
Total.
Um, I'm trying my best.
I see it. Looks pretty good.
Okay, I'm just gonna, oops, bring that down there. That kind of looks like a second carbon.
Kind of does, but I see what you mean. We just there's one really long there. There's one
Oh my
really
God,
ugly.
I have the highlighter now.
Perfect.
How do you
There,
can't undo
perfect.
something? Oh yeah, you can. There you go.
Bottom left. Yeah,
Okay,
there we go.
perfect. 10 out of
There
10.
we go. Perfect.
Okay. So I'm gonna change the color and then I'll show you how I name them.
Your method, yeah.
But you start off, so my first carbon is right here, my second is right here, my third, and then my fourth. So hold on. I just realized what I did.
Hmm.
My bad. Actually, I think your one is right here.
The
Damn it.
peak.
Am I wrong? No.
I mean, for like this one, it doesn't really have any like groups on it, so I guess it doesn't matter too much.
It
Do you think?
doesn't matter so much, but hold on.
But I feel like there definitely is
It's like
a
this.
standard to
One, two, three. Is that's not a three. Okay, just pretend that was a three.
Mhm.
And then this is gonna be four, five, four, five, six, seven.
One,
I'm
two,
missing one. Seven, eight.
one, two,
Oh, no, no,
three,
no, got it, I got it. Okay.
4, 5, 6, 7, 8. Yeah, I
Four,
see it.
five. Sorry, it's just because I drew my structure bad.
7, like
Six.
that, right? 6, 7,
Yeah.
8. You go
Well,
back
I
up
mean, it would go
and
like
around.
seven, eight, but yeah. And
Oh,
then so my first number that I'm looking at, if I were to just count all of them total, and then your eight, yeah, your eight goes there. Perfect.
hmm.
So you could just see that this, because there's eight carbons, that's obviously an octane. So that's
Hmm.
going to be your bicyclooctane. And then you're going to count, you're not counting this area. That doesn't go on your number. You're counting your first carbon, your second carbon, and your third carbon, because these ones don't touch the center area.
Okay.
Okay. And you're counting your one, two, three. So that's going to be your first. It's going to be, you're going to start off that you have three on the first side. And
3
then you'll see one, two right here. These are the only carbons on this side that you're going to include in the second one.
on their own.
They're not touching the center. Maybe I'm not doing a great job explaining, but
I see what you mean. Yeah, they're not like connected to that like
yeah. And then
inside
right
there.
here, this, let me change the color. Right here, when it's straight here, there's no carbons that we're numbering. So we would name that as zero. There's no carbons in the center. Does that make sense?
Yeah.
So if there was, so this right
Well,
here,
I think
if that was like a supposed to be a gap or that's supposed to be an indent, you would count that as one.
like that, right? Is that sort of what the molecule looks like?
Oops,
There's that,
let me go back. There you go. Yeah. No,
right?
no, no, no. So you have a this right here
One, two,
represents this.
three, 4, 5, 6. Why? I think I drew too many. I drew
Yeah,
too
yeah,
many
yeah.
lines here.
So, okay, wait, wait, wait. Leave your structure and I'll show you how to like count this one. Okay. So for this one, let me change my color. For this one, you have a total of,
Oh, because
yep.
total you have no. Oh, because total carbons you have 8. 1, 2, 3, 4,
Yeah,
5,
you
6.
have eight because you have one right here, one right
Including the one in the
here.
middle. Oh. So I
This
actually did
structure,
do.
this one's a little bit, so this original one is a little bit different because I drew it kind of bad, but this area goes like straight down. Oh my God, this is turning
No, I
into,
see what you mean. Yeah. So what you the one in the question, the one you drew, is like a cycloheptane, but with a thing in the middle.
the original structure.
That
Yeah,
one, the
I
one up
guess.
here, yeah. Because right here, this is like sort of like a cyclooctane, but then there's like this 9 in the middle. So it
Yeah,
would be like a bi can we bicyclo
no name.
uh
So
do you do like 3 3, I guess?
for this one, you count here
It's the same. 1 2 3,
three, and then
and
you
then
count,
these
yeah. And then your last number is
3 3.
going to be a one because you have one
Yeah.
carbon in the middle.
And it's a nonane, right?
Yeah,
Nonane. Okay. See, Loki, I think I might have named this an octane by accident, so thank you for that.
you're welcome. I hope I'm right. God, that
No,
makes
you're right. I mean, yeah, that's the one on the
I just want to double check my work because I do not
oh,
want
for
to get
this
it wrong.
top one, Jaslyn. Yeah,
Yeah,
she's right. Yeah, this is
you said yeah.
this is the one for the one in the middle, that one here.
It's a one?
For this guy, for that carbon that you're pointing at. I mean that I'm pointing at. It's what? It's on the answer key too. 1, 2, 3, 4, 5, 6, 7, 8.
What did I do wrong?
Because this one represents like how many like extra carbons there are in the middle, right?
One,
So it's like
two, three,
that.
4, 5, 6, 7, 8. Is it, was she saying, I don't know what triangle I drew here, first of all.
Boom, boom, boom. Oops.
I can't erase it.
Here, trying here. Oh, I can't erase that either. What is that?
I'm not sure what it is.
Oh, hold on. There you
Oh,
go. There we go.
nice. Okay, is it, my bad. Is it this intersection that was one?
Okay, so like this one now. Let's just do this one that I'm drawing down here. 8, 9, 10. Right. Um,
Yeah.
so then this one would be not 3 3. It'd be what? 1 2 3 4. 1 2.
One, sorry, I wasn't
This one
looking.
would
Three,
be
four,
4, right?
5, 6, 7, 8, 9, 10. Yeah. There's also, I have a couple of examples.
4 2 2 because of these 6 and
Hmm.
7 by themselves. And then 2
Two.
again.
Yeah.
And then it
I,
would just be like decade.
yeah. And then I can also
Yeah.
show you. So if you were given like draw by cyclo,
Because this 9 and this 10 are this 2. Yeah. Yeah.
oops, like that. If I were given by cycloheptane, I would go
Bicyclo 2 2 1 heptane.
one,
So total carbons has to be 7, right?
yeah.
In the whole thing. Yeah, so low key just draw a hexane, a cyclohexane, and then yeah, like that.
Right, one, two, three,
Yep.
four, 5, 6. Okay. And then I just go like this. Okay. So this right here is
Yep. That
the
your one.
7. Okay. So if I were to now number that, just for the sake of it. One, okay.
There.
Apparently, I have to pay for this meeting in 10 minutes.
Do you
I just
actually?
got a notification.
Sorry.
Um,
Yeah, yeah. So
yeah.
there's your both sides, and then the one in the middle. Yeah,
Yeah, there you go. That's how you need them. I personally feel like they're pretty easy.
yeah. Okay, that's not bad.
Yeah,
Okay,
and
do you
then
wanna?
what's up?
I feel like we're good with this question.
Yeah,
Yeah.
I would agree.
Do you want to close the meeting and like open it again, or
Does that even work?
is it gonna? Is it gonna? Because it says like time left, like 4 minutes, right?
Yeah, you see that? Okay. Oh, how do
So I
I
think
leave?
you could just make a new one. You just like end this one.
Okay. Well, let's finish up the 4 minutes.
Okay.
And then we'll just because if we can go
Um,
over discussion,
which one?
be one recording. Okay, we went over four. If we can, okay, let's go over discussion three and then I can end it.
What's discussion three?
The free res like the if you scroll all the way down,
Oh, all the way down.
yeah, where it starts to say one, two, three.
Discussion questions. Yep. One, two A, two B, two, three. Draw the structure. That's all it's saying. I'll type it
Okay.
out here and you draw it. Don't look at it. Don't look
Okay.
at it. The pressure's on. Method
You're good.
three.
I was struggling too.
Um, so that is what they said.
Oh, maybe I shouldn't have done that. There.
You have 3 minutes before the world explodes.
Okay. Thank you. Um,
Trans 1-methyl tert
okay.
3
Cyclohexane.
tert. Yeah, cyclo methyl 3 tert butyl cyclohexane.
Oh,
Pretty good, pretty good.
not bad. I was struggling with these. Okay.
Guy, right?
And then let me just, so if the area is bolded underneath, that means it's facing you.
Mhm. I don't think that crazy matters, but yeah, usually it's the bottom.
Yeah, I don't know. I'm just saying it to say it. Um, okay.
And this is R1. This is
And then
R2.
this is right here.
Well, I guess it doesn't matter too much, actually.
Let's just do that like that. Does that look similar? Kind of, not really.
Yeah, yeah.
Okay. Okay.
And one side.
Cyclohexane. So
Yep,
trans.
trans 1-3. And then the reason,
Here.
my God, this is the worst. Hold on. Hold on.
I'm just gonna go like this. I'm just gonna highlight the areas
I
of
like
where
drawing
they
mine like
are.
this. Do. No, not that. My goodness. Hold on. 1 minute. Turbidal.
They're gonna look so good.
My goodness, this is really, really bad. Hold on, I want to give the bad example. Okay, so this up, down. That makes sense.
Yeah, it makes sense. It makes sense.
This would be the bad example, right? Because the key is the trans, and both of these are facing up. So this would be
Yeah.
cysts, right?
Yeah.
This
And
one's
because
up, and then
one's
this one's to
up,
the
one's
side.
equatorial.
Yeah, exactly. One, two, three.
Nice.
Even though this would still be 1, 2, 3. Yours is also 1, 2, 3, but just in the other direction.
Oops, there you go. Okay, how do you one yeah, three, four, five, six. Okay, yeah, there you go. And
Yep.
then the whole structure itself is the cyclohexane.
Butyl cyclohexane, 3 terbutyl, 1, 2, 3.
Okay.
Yep, terbutyl.
Nice. Under less than a minute. Okay.
Less than a minute.
And the
Turn your
reason
chair. Hmm.
no, just for the sake of the recording, I was just gonna say the reason that we're naming to the left is because we want to get both substituents to be the lowest and to follow the 1, 3.
And to follow the trends. That's right.
Um, which
Because
we I guess explained.
if we did 1, 2, 3, this one goes up, this comes down, this one goes up. So then it would have been cis in that case if we did
Yeah,
that. Mhm.
that structure just doesn't even look right. But okay.
That's correct.
So, and then if we work on
Alternative chair.
A right over here. Perfect. Okay. Draw the alternative chair conformation, so automatically we know that it's flipped.
The other way.
Oh, don't mess up. Come on.
It's like infinitely easier to draw to draw on real paper.
Seriously. I've never drawn on a computer before. Okay.
That,
That kind of looks really bad. Should I redo it or should I
that's
save
how
it?
it's gonna. Well, I think. Hold on. I can. Let
Here.
me do this bit. Hold on. Hold on. No, no. You were right there.
You go, you go.
Oh,
Jump scare.
wait. Your mouse isn't. Your name is in the way.
Sorry.
Uh, yeah, like that. What am I
I don't
doing?
really think it was my fault, but
Down. What am I doing? No, it's up. Okay, hold on. Hold on.
you got
It's
it.
so like this is the real. This is look. This is the hard part.
Here.
This is the real hard part. All right, you start. You go. Get you go.
So I'll start
You
us
just do
off.
parallel lines the other way. Yeah,
Okay.
like that. There we go. Yeah, and then you go like this and like that. Oh, we did it. There we
Nice.
go.
There you go.
Or
Okay. That's the
okay.
opposite. Finally, this
Mhm.
is gonna be the hardest part. And
Okay.
then
An alternative chair. This is your one.
so
That's
everything just
just
literally,
something to know. This is your one right there.
yeah. And then if you're flipping it, you're also, this is gonna become equatorial now, and this is gonna become
Smart
axial,
vocabulary. Yes. Will come out that way.
and it'll still be trans because they're opposite. They're
Mhm.
facing opposite directions. Okay, and then right
Exactly.
here is gonna be two, and then this could probably be a sharper point, and that will be your
Equatorial goes
three.
about that way.
And then this off of here is where you see the turret butyl.
Hmm. And
Okay.
that's because in all these chairs, this one goes up, this one comes down, that one goes up. So that's
Um,
why this chirp beetle is going down. And they're trans.
okay, nice.
Nice. Okay.
Is there any difference in stability of these two conformations? Explain using the strains to, so for strains we have, let's see, we have the strain. I'm just gonna write these off the top of my head.
I would say I'm not even reading that paragraph. I don't know. Is that her handwriting, you think?
I think so. I don't know who else also that would be.
All right, this is my thing, my point of
Okay.
view.
Oh, that's what I thought.
She said that, well, also textbook and workbook or whatever. All the ones facing up, up, down, up. Oops, not this one. Sort of like make a cloud of disturbance up here, right?
Yeah.
That's like bad. Oops, and same thing applies if they're pointing down because it's like, up and down. So in this case, and equatorial, they're like more alone, right? So in this case, the equatorial butyl is kind of like not really bothering anyone, but this one is making a lot of disturbance because it goes up, uh,
Okay. Could you say it's
down, up,
because the one
down.
with more carbons?
They have the same amount of carbons.
No, I'm saying like the one
Oh,
with, as long as the one with more carbons is equatorial, the whole
yeah, because
thing.
yes, yeah, because this one is also doing some like strain, but not as much as the terbutyl group is,
While it's
right?
facing downwards. Equatorial is
Yeah,
always
well,
going to be
because
more stable.
that's basically just the answer, I'm guessing.
Yeah, she said the tert butyl grouping, a larger group than the methyl, causes more steric strain in the axial position than the methyl group. So essentially, right here, like right here, is where you're seeing a stronger strain between these two.
Yeah, because there's like a
Let me get out of here.
not between, I don't think between those
Not
two,
between
right?
them? Oh, my bad.
No, because it's there's hydrogens here. So there's a hydrogen here, there's a hydrogen here,
Wait,
right? So
yeah.
like these hyd oh, the yellow is a bad color. These hydrogens are bumping into the tert-butyl group
Oh,
down
that makes
here,
sense. Okay.
down there. They're bumping into it down there. Up here on this one, you have a hydrogen group up here and here.
Mm-hmm.
So the methyl group is bumping into them, but not as badly as the tert-butyl group.
10 out of 10.
10 out of 10.
Okay.
All right.
Um, okay, nice. And then the other thing, I guess she just said, number one, okay, which of the following statements is true? All molecules have chiral centers. All molecules that have chiral centers are chiral. I feel like that's pretty straightforward.
I
Um,
think it's
C
wrong.
is false because you just have to know the definition. So all enantiomers are non-superimposable.
Wait, I think you're saying it the other way around.
What did I say?
You said that C is false.
I mean, C is right. C is right.
He's right. Yeah.
Sorry,
Yeah.
C is
Yeah.
right.
He's right. He's right. He's right.
C is right, and enantiomers are
Yes, he's right. He's
non-superimposable
right. This is the
images.
gaslighting study group. We're trying to throw people off. We're trying to lower the curve. Uh,
I'm sorry, I'm tired. Okay, let me
crazy. No one's ever
be
gonna trust
quiet.
this recording.
I know I made so many mistakes in this. Whatever.
It's fine. Okay, let's say why all these are wrong though. Let's explain it. Okay.
Okay.
All mirror images are enantiomers. I'll give you an example right now. Boom, 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 boom. These are mirror images if the mirror is in the middle, right?
Yeah.
And they're not enantiomers. So just because there's a mirror image does not mean that there's an enantiomer. Doesn't like guarantee it, right?
Yeah.
Yeah.
Um, there was
The
also
other one,
what is no, that's a meso compound, right? That I'm thinking the plane of
yes.
symmetry. Okay.
Um, s- oh, like an internal plane of symmetry.
Yeah, and an internal plane of symmetry is a meso.
Yeah, that's sort of like like that option B, where it says
Yeah.
all molecules that have chiral centers are chiral. Um, I was speedrunning, so I low-key got this question wrong during the pop quiz. But
Is this on the pop quiz?
yeah, I was. I said which one of these ha are have
Let me
which one of
look.
these molecules are chiral? And this is one of them. It's burned into my brain because I know I got it wrong afterward. So this one has two chiral centers. There's one on the left, there's one on the right. But because of the internal plane of symmetry, it's a meso compound, which means it's achiral. So just because it has chiral centers, it doesn't guarantee that it's chiral. If we do this, now there are two chiral. This is not an internal plane of symmetry.
Because one's in the front, one's in the back.
One is in the front. Yeah, this is trans. So this is chiral.
Yep,
Um, yeah,
there you go. Okay,
there we go.
perfect. Alrighty, and then for D, that's false because enantiomers are non-superimposable images. They are not
Mhm.
superimposable.
Yeah, D says superimposable structural isomers are enantiomers, but that's just wrong. They have to be non-superimposable.
Yeah, at that point, yeah. Okay, two, which of the following is the definition of a meso compound?
There we go. Again.
Um, oops, what it? Can we go over chapter 5, slide 36? Yeah, let me pull up what that is.
I'll go through this meanwhile.
Okay.
Um, A says a molecule with chiral centers, which is chiral. Okay, well, if a molecule is chiral, then it's not meso. This is a definition thing, right? This is like another definition thing. Um, the other thing says a molecule with chiral centers, which is not chiral, and that's true. This molecule, this 1,3 trans 1,3 dimethyl cyclohexane, which is what I drew right here, is meso because of this internal plane of symmetry. So it does have chiral centers, but the whole molecule itself is achiral.
Okay.
Option C says a diastemer with no chiral centers. That doesn't even make sense. I don't even think that doesn't even make
Let me
sense because
look at
a diastemer has to have at
has to
least
have chiral centers
yeah, it has to have chiral centers. That's not even a thing.
because it's you know if it's a diastereomer based off if some of the chiral centers have changed, whereas in an enantiomer all of them will have changed.
Exactly.
Shout out to
And then the
organic.
last option said a chiral centers. a chiral compound with more than one chiral center is just that's just wrong.
Yeah,
That's just
not
wrong.
really specific.
What was the I saw that. What was
Okay.
the
So
learning check?
the chapter 4 learning check, or I have it, sorry.
Hmm.
I can I can start off. I don't know if you have a specific one that you need help on, but I can just start us off with A in the meantime. Um,
Is this like textbook or
Or I
is
could
this a
share my
PDF?
screen. Nah, whatever, let me just do it. Yeah, it's on the lecture slide.
Oh, I see. Which of the following are, oh my goodness, which of the following are meso
I know there's
compounds?
so many.
Yeah,
But starting off with A, if we look at the definition of a meso compound, it's having an internal symmetry. Am I forgetting the first part?
yeah. Internal plane.
Internal plane of symmetry.
Hmm.
Okay. So right here, you can see that all, for A specifically, all of the molecules, there's a plane of symmetry between the two, because if you were, yeah, to split it, you would see the exact same molecules right here. Why am I on highlighter mode? And here on opposite sides. So if I were to fold it in half, they would be placed on the exact same spot.
Like a taco,
Yeah,
like folded.
exactly like one. It would be the exact same compound
Hmm.
or structure.
I
Um,
think for
and then
the I was gonna say for the what's it called? Um, boat conformations. I think it's easier if you just draw out like a normal cyclohexane. Like it's easier to spot. You know what I mean?
yeah,
Because I feel like the
that
boats
sounds
are
true.
kind of weird to look at.
That is true. You want to draw a cyclohexane
Yeah,
next
I'll
to it?
draw like D,
One,
I
two,
guess.
three, four.
Um, oops.
Oh, you're gonna do D? Okay.
I'll do D, sure.
Should I leave this here?
Yeah, leave it there.
Okay.
Just remember, on a on a boat, not on a boat, on a chair, sorry. This is our number one, and I'll just put our one here for why not? Um,
You're going over D. Okay.
yeah, D. So in this case, we have a methyl group which is pointing down, so it's gonna go away. And then down we have one go coming up, which is an OH group coming up. And then on the other side, we also have a, is that up?
The OH is up.
It is up. Yeah. We have another OH group. Okay, so this one's not too bad.
Oh, wait. So one is up and then the other one's equatorial.
But they're both up. So
No,
the methyl group is down. Like
isn't the
up,
OH down too? I mean, equatorial.
yeah. So like something can be up and down axial or up and down equatorial.
Okay. So how do you know if it's up equatorial?
So the up equatorials, so
If
this
it's
is a
just like this or this slanted?
yeah, so this where's my marker? This is facing up. This is up equatorial right
And then
there.
the second one would be the
There.
H and that would be down.
Hmm.
Oh, okay. Never
And
mind.
then you see how so it alternates, right? This is down, then up. Then there's one that comes down,
Yeah.
and then up, then down, and then up again, like that. Okay, the other way, but it's up,
Yeah.
up, upwards. So that means that it's going to be facing towards you.
Got it. Something.
Okay, so that one, it is a meso. Oops,
The
meso
meso because again, the plane of symmetry,
plane
the
of
OH on both
symmetry.
sides are
Mhm.
identical. So it's the
Yeah,
same thing, like if you were to flip it over or like flip it in half, the OH would be placed on the exact same spot.
they're like this is a pretty actually it's good. If we just draw E real quick, E is similar except your methyl group is pointing up and then your OH is going down, and then your other OH is going up. So this is not.
E
Yeah, this is
is
E.
not.
Not meso.
Because if I flipped it, it wouldn't. This means that it's in facing towards me. This is behind the structure. So if
Mhm.
I flipped it, this would still be behind the structure and this would be up in the front.
Yeah, D was not meso.
D was
Well,
not. No, D was.
okay, definitely was. This is an example of something not being
E is
meso.
not miso.
E is not meso, yeah. Maybe,
What?
I don't know. No, it definitely is not though. The other one definitely is meso. I
Yeah.
think it is a little confusing though, like sometimes converting the chair to back to a normal cyclohexane. No, no, you're good.
I have no
But
clue what you just said.
I think that is good to remember. Like when something is pointing up, like this is an up axial, right? That just means it's like a solid line, like a solid chunky line. Uh, but
Wait. Oh,
when
sorry.
something is pointing up, this is also up, but this equatorial is still a chunky line. And then you also have the downs, right? You have a down and you have a down here. These are both down.
So D is not. Wait, I'm so confused. I just saw her
D is
message.
meso, D is meso. Yes.
It is? Okay. I'm
Yes.
gonna
We
ask
we drew it.
ChatGPT
We
really
drew it.
quickly.
We drew it earlier.
I'm asking ChatGPT just to make sure.
Sure. And then remember how I'll just keep yapping.
Okay.
Remember when we're doing our axial stuff, it goes up, then down, then up. It alternates, right? Down, then up, and down. The
Oh,
ups
it
and
is.
downs are up. What's up?
D was a miso compound.
Yeah. The ups and downs are alternating, right? And it's the same thing for the axial. So we have a down, and then we have an up, and then we have a down, then we have an up, then we have a down, then we have an up, like that. So everything alternates up and down. And again, that just means either dashed or a solid line.
Nice. Okay.
Nice.
Should we go back to exam two?
Yeah, I think we
Okay.
can.
Okay, nice. We're on question three. Which of the following structures is different from the other three?
Can
Uh,
I screenshot this?
how are we gonna do this?
This is just hold on. Let me see if I can upload a picture here.
Wait, and you put back what you can you put back what you erased? Yeah.
Oh, yeah, that.
I think you meant to put one of them purple
Wait,
or
what?
not. Or are you trying to represent which one would be down and which one would be up? Okay, yeah, that works too.
I just draw like that. I'll label a few of them.
There you go. And then I'll upload the Zoom to the Discord. Okay. I could.
Hold on. Maybe I can upload my device. Let me see.
Can you upload an image?
Maybe. Oh, do you see this?
Oh, nice. Okay, I see
Nice.
it.
Perfect.
Let me.
There we go. We'll just go under it, I think.
You just put on top of all of this.
On top of what?
Oh, never mind. I didn't know you could scroll down.
You
LOL.
just moved.
Yeah, I
Just
erased
destroyed
everything.
the
I did
whole.
not know that.
You just destroyed the whole whiteboard. That's fine.
Oops.
Okay.
I could
This
undo
is
everything.
asking, what's the question?
Okay, there, let me just undo everything. The question is which of the following structures
It's
is
different.
different?
And it's asking for R and S, basically. That's how you check. Because they all have the same groups attached to the chiral center.
Yeah.
Now,
Okay. Oh,
okay,
it already has the answers on it. LOL.
what's your method? Yeah, how do you,
My
because
method.
I think a lot of people are gonna mess up the counting the R and S basically. I think a lot of people are gonna mess it up. I'm not gonna lie.
So you have to assign priority.
Yeah, I think that part's not too bad.
Um,
I'll give you an
and
example
then,
of some tricky ones.
oh, thanks. I have the exam for that. No, I'm just kidding. Um,
Where's
okay,
the
I'm just
hardest
gonna
one?
put assign P. For the first one, my highest one is gonna be bromine because that's what it says on the periodic table. I already know hydrogen is my fourth. And then the ethyl comes before the methyl, right? Right?
Uh, it's a higher priority.
Right? Yeah. Okay.
Yeah.
Oops, that's supposed to be a two, not a three.
So
Okay.
the way we assign priorities, just for everyone again, you go out one, right? And then so in this case, you find
The higher
a
the
carbon
atomic.
and a carbon. Yeah, higher atomic number,
Hmm.
higher atomic number. But when they're the same, like a carbon and a carbon, like you see what they're connected to. So
Yeah.
the methyl group has like three H's, and that carbon, which is part of the ethyl, it has two H's and a C. So the two H's and a C beats the three C's, the three H's, sorry, the three hydrogens.
You're gonna look at the next point of difference, or the
The
first
next
point of
one.
difference, sorry.
The first, yes. That.
And that's that this one has, okay, whatever. I was gonna write
Okay.
down his rules, but it's like the con rules.
Um,
Um, yeah. So because this one has two carbons, takes second priority.
Let me draw.
Um,
Okay, you explain your method of
I'm not a good explainer.
It's true. It's this is really difficult, or like
I
it can be,
know.
because some of them look obvious, but they're not. And I'll draw an
Okay.
example. I have a workbook here, and I'll draw an example of one.
So I draw mines like this as a clock, and then I had to go back there. So like, let me actually redo that. So my starting point is my one, then I follow my two, and if I follow my two, I get to my three. And like if you repeat the cycle, you get to your four. So that means that I'm going counterclockwise, right?
Hmm. No, it's not too bad. Yeah.
And then that's basically my S. That's what my S is. My S is counterclockwise, and my clockwise, why is my pen so thick? Is an on.
It's wrong with the little.
That's what I use to identify this.
Yes.
Yeah, you can show your way. I
What
like
about look? What about that number?
which number?
See which one breaks that a little bit. What about three?
Ugh, jump scare. Okay.
That number three up there.
Okay, let me just make sure my pen is a little thicker. So this is one, this is two, this is three. That just look like a three, whatever. Three. This is four. This is going counterclockwise. Oh, for this one, the rule is ooh, if it's flipped,
Yeah.
you look at
Okay.
it. Okay,
That.
you finish explaining.
Okay. No. No. I'll give a method. I'll give a.
Okay.
I'll give a What's it called? Like a everything method. Like this will work for everything. So let me
What's it
give
called?
you an example. Okay, if you have this is just a rule. This is just a rule, okay? If you have, let me draw again. Let me draw this. I'll draw that. Hold on, bear with me. One, four,
My screen's being recorded.
two, and then we'll have our three, two, one, four. Okay. Um, okay. So when you have a chiral center and you change and you swap any of the two groups, you change its handedness. So if you have a chiral center that is S and you swap two groups, like their position, if you like take, they swap them, the
Oh.
molecule becomes R, right? So if you have an R-handed chiral center, you swap two groups, it becomes S, right? So when you have a when you have like counting that clockwise, like the easy clockwise, it's really obvious when your least priority is on a dash, like going away. That's like when it's really, really obvious. Um, and it's like it guarantees you that it's correct. So in this case, like on this left one here, if my priorities, I mean, you can see like one, two, three, four, right? Um, this one's pretty simple. It goes like that. So it's S. I mean, so it's R, right? Because going clockwise. And because I switched, you see how I switched groups two and three? Without even counting or doing anything, I know this is S. That is just like a rule in chemistry. And you can also count like that. It goes past that one.
But
So
looking,
for
oops,
mhm.
my bad. No, go ahead.
Okay, so I was just gonna point out this one down here, which looks pretty obvious, right? Um, this one, I think a lot of people would see this and they would say one, two, like, like how do I count this?
Yeah.
They might even say, so the easiest way to guarantee your counting is to put your priority for your least priority on the dash to put it facing away, right? So I don't know what this bottom, I don't know if it's R or S. I don't know. But let me do a swap. So if I swap this, right? So I'm gonna put the four up here, just like in my head, temporarily. I'll put the four here and I'll put the three here. Now it's pretty obvious, right? This looks like it's a an S, right? That's pretty obvious. But remember the rule, if you switch two groups, it changes the handedness. So if this is S, but I swapped it, so that means that the real thing is gonna be going the other way, which is R. So remember the original was four and three. Um, in your head, if you just go, okay, let me just quickly put the four over here and let me swap positions. Whatever direction you have, okay, cool. This looks like it's S. But because you swap the groups, it changes the handedness. So before you changed it, it used to be R. Um,
Wait.
I don't know if that's a little confusing, but
Okay, never mind. No, you're saying it right. Okay, I hear good.
yeah. So the basic is if you have a chiral center, this is just like a law, like it's just a thing. If you switch the position of two groups, it changes the handedness. Um, so basically, the reason I'm changing it in my head, right, is to make it easier to read. Because this right now, this bottom one looks really ugly, like hard to read, like I'm unsure. Um, but if it was like three and four, like that's a lot easier to read, right? After I've swapped it. But after swapping, it changes the handedness. So just unswap it, if that makes sense. I'll give you the example with this one. So with this number three over here. So with this number three, you said our first priority is this bromine, and then it goes two, three, four, right? So then we'll just say temporarily in my head, I already assigned priorities. I'll say in my head, actually, I'm gonna swap this one and this one. So it's like that, right? So now I do my counting. Okay, I swapped it, and it looks like it is going counterclockwise. It looks like it's S. So it used to be R, which is what it is right there.
Got it. Okay. So
So
it's what it used to
basically,
be.
you switch them temporarily, and then when you switch them back, it's the opposite of what you determine it was.
Exactly. So you just switch to the numbering, the priorities temporarily. So I have my priorities here, my one, two, three, four, that's the right priority. But to guarantee that you're going to get the right counting, the lowest priority, your number four, is on the dash. And then guaranteed, like you'll read it correctly. Which is really easy on some of them, like on this one over here, right? On the one on number four, you have a one, two, three, four. This one's easy to read because you can just, the H is going away. It's far in the back. It's far away. You can just count this way, right? One, two, three. Then it's S because you're going this way is counterclockwise, so it's S. So because the four, you see how the lower priority is on the dash, it's far away. You guarantee it's pretty easy to read. For this one, for number three, this problem in the middle, it looks kind of tricky. Um, so you can say, okay, I can guarantee it'll be easier to read if I just put the four, like it could be any groups, any two groups. But I'm gonna put the four on the dash and I'll just put whatever was there. I'll just switch them. And now I can do my normal reading, which looks like it's S, but because I did the swap, it's actually R.
Okay.
Yeah.
That was
I feel like someone would just see this one, two, three, and
yeah.
say that it's S, and then they'll just be done, which is wrong.
Yeah, but at that point you couldn't even figure out what the priority was because
What helped me with those is that if the H is on a dash, that no matter
Mhm.
what, it's gonna switch whatever it is, if that makes sense.
Like it'll the
like you'll swap, you think?
like
Which
if
is
it
right. That's what you did
yeah,
for number
sort of,
three.
yeah, sort of, yeah,
You swapped the H
yeah.
and the CH3. Okay, nice.
Yeah, that way makes it more simpler to identify what it is. But thank you. Yeah, that helps.
Hmm. We can do.
Perfect.
I don't know if she'll do this, Fahima, but you can figure it out.
For what?
I'll give you I'll give one other
Example?
what's it called? Example for yeah for rotating. Let me just pull up a random example. Here, I'll draw one here. This is a Fisher projection, by the way. Where's my mouse? Whoops. Uh, you see, I'm like a little more down. Move them more down.
Oh, okay.
You have like a let's see, CH2, CH3, CH2, CH3. It's an ugly ethyl group. Br and H. Okay, so can you find the which direction this goes? And then can you remind us what a Fisher projection represents?
Me?
Yeah.
Okay, fine. Okay, vertical bonds face away from you
Mhm.
and